Hello, ladies and gentlemen. Today we're going to talk about lesson 3.4, which is parallel lines and transversals, a little more with it. Today we are actually looking at the measurement of angles related to parallel lines and transversals. So right there, specifically angle measure. Our goal is to find the measure of those angles that are formed, and then we have our list of keywords again right here. Same words as last time, so no new names, just doing some different things with them. Okay. All right, so right here what we see is the baseline, sideline and service line and baseline of a tennis court. Think about this for a second. You know that this sideline right here runs, well, it's along the side. So what do you know about this sideline and this baseline? Hopefully you know that that's going to form a right angle, that this is actually 90 degrees. Although it doesn't look like it right there, just because it's kind of sitting at an angle, you know in your head if you've ever been on a tennis court that that's what it is. Now how about this service line right here and the angle it makes with that side line? Hopefully you know that that is also 90 degrees. So think about that for a second. We've got 90 and 90, and then what kind of angles are those? Those are corresponding angles. Would you say that the service line and the baseline are parallel? Hopefully you would, if you remember what parallel means. Okay, so here's a postulate, corresponding angles postulate. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. Corresponding angles are congruent. I don't think you can see that very well. Let me write that in a darker color. That's better. Okay. All right, so if you think about that for a second, angle 6 right here would correspond to angle 2. So those would be equal to each other. So right here in symbols, if J is parallel to K, then the following are true. Angle 2 is congruent to angle 6. Some more, they're color-coded. 8 and 4 would be equal to each other. Angle 4 is congruent to angle 8. 1 and 5, those are both in that upper right-hand corner, so those are corresponding. Angle 1 is going to be congruent to angle 5. And then the last set in green, angle 3, is congruent to angle 7. Okay, so if they're in the same spot and they're made by parallel lines cut by a transversal, they're corresponding angles, and therefore they are going to be congruent. Okay, we can write that kind of in short form. If parallel lines, then or therefore corresponding angles are congruent. That's short form of that theorem. Remember, you guys can pause this at any time if you need to go back and look at something or rewind it. Visualize it. So this is just kind of something, to look at. When you're looking at corresponding angles, you're always looking for the angles that make that F. So notice right here, these are both in the lower right-hand corner for the two different intersections. On this one, these are in the upper left-hand corner for the two different intersections. So they have to be in that same location. So this reminds you that corresponding angles, and they are always congruent as long as those lines were parallel. So here we're going to find the measures of corresponding angles. So find the measure of the numbered angle. So this number 6 right here, these arrows mean that the lines are parallel. So always look for those. So since I know that these two lines are parallel to each other, then the measure of angle 6 equals 60 degrees. The measure of angle 6 equals 60 degrees. Okay. Then for number 5, angle 5 in letter B, same thing. We have parallel lines right there. So then the measure of angle 5 equals 135 degrees. Don't forget your degree symbol. That's a notation thing. And then right here, letter C, again, we have the parallel line markings. So that means the measure of angle 2 equals 90 degrees because all of these are corresponding angles of parallel lines cut by a transversal. So they're congruent. All right, here's another theorem. This is about alternate interior angles. So if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Alternate interior angles. So think about this angle right here, angle 4 and angle 5. Okay, those are on opposite sides. The neat thing about these is they kind of make a Z shape as you make those, or as you look at that. And then that 4 and that 5 hopefully are showing that they should be congruent to each other. So if J is parallel to K, I'm looking at the symbols now, then the following are true. So for this, angle 4 would be congruent to angle 5, and angle 3 would be congruent to angle 6. Again, look for that Z shape. Alternate interior angles. So then in short form, I wrote one for the other one, if parallel lines, therefore, or then, alternate interior angles are congruent. It's just a little short form because you often have to write explanations for why you're saying certain measures are there. Okay, so that you can write that for your explanation. Okay, let me move this out of your way. So you're going to find the measure of angle PQR. Okay, I got to tell you, you have to make sure that you know where PQR is before you can figure out what it is. Okay, so PQR, remember, you just trace it with your pencil. So I start at P, go to Q, down to R. So that means I'm looking at this angle right here. Okay? So the measure of angle PQR should equal 35 degrees. Okay, we know that we have parallel lines right there. So these are alternate interior angles formed by parallel lines, so their measures are congruent. Same thing here, parallel lines. So PQR is right here. I'm looking at this angle. First of all, I should realize that that's going to be obtuse. Okay, and then since it's alternate interior with the angle marked 120, the measure of angle PQR equals 120 degrees. And then the same thing on letter C, parallel lines, PQR, so that's right here. And that's alternate interior with the 70 that's on this spot. So then the measure of angle PQR equals 70 degrees. One more, or another theorem, there should be 4 because we have 1 for each of our special angle pairs. Alternate exterior angles. Okay, if 2 parallel lines are cut by a transversal, then alternate exterior angles are congruent. Are you noticing a theme here? So far, all of them have been congruent. Okay, so in the symbols, if J is parallel to K, then the following are true. Use that color coding. Angle 1 is congruent to angle 8. And angle 2 is congruent to angle 7. Angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. And again, they're short form. So if I have parallel lines, then, or therefore, alternate exterior angles are congruent. If I have parallel lines, then alternate exterior angles are congruent. So right here, find the measure of angle 1 and angle 2. So think about this for a second. 75 right here, there's really no relation to angle 1. Okay, no relation at all. But if you look at angle 2 right there, that is an alternate exterior angle to the 75-degree angle. So I can look at theorems about alternate exterior angles, and then I should realize, oh, alternate exterior angles are congruent. Whoops. Forget it. We'll just go ahead and put the thing down. We know that alternate exterior angles are congruent as long as the lines were parallel, which we have those markings. So therefore, the measure of angle 2 equals 75 degrees. Okay, but I didn't have to just find the measure of angle 2. I also have to find the measure of angle 1. So if I know that this is 75 degrees, then now I can do some work to figure out angle 1. Okay, look at this whole thing. This is a straight line. How many degrees make a straight line? 180. So then the measure of angle 1 is going to equal 180 minus 75. So the measure of angle 1 should equal 105. Those should be supplementary. Okay? All right, so this is a checkpoint. I would pause this now and then try these problems right here. So let's see how you did. So use the diagram to figure out what the missing angles are. So angle 1 and angle 8. So look at this 120. 120, you've got a lot of stuff going on. You've got 120 right here, and it is vertical with the 7. So angle 7 should definitely be 120. Okay, we're going to tell whether the angles are congruent or not congruent, and then we're going to explain. So that's going to be 120. 120 also corresponds to angle 2. Well, 7 also corresponds to angle 3. So if you look here, you have two pairs of vertical angles that also happen to tie into the corresponding angles thing. And remember, vertical angles are congruent. So 7 is 120, 3 is 120, and 2 is 120. What do you think about 1, 4, 5, and 8? Well, those should all be congruent also. Do you know how much they should equal? Those should be 60. 180, whoops, minus 120 is 60 degrees. So this should be 60, 5 should be 60, 4 should be 60, and 1 should be 60. If you have two parallel lines cut by a transversal, you truly only have two different measures. So let's see what we got for answers here. I guess I'll use yellow. Angle 1 and angle 8, well, what do we see? Angle 1 is 60 and angle 8 is 60. So we're going to say congruent. It didn't ask for the measure, it says are they congruent? But sometimes you have to figure out the measure to answer the question. So angle 3 and angle 4. 3 is 120, 4 is 60. So that's going to be not congruent. 4 and 2. 4 we figured out is 60, 2 we figured out is 120. So that's going to be not congruent also. Okay, but we had to figure out the measures in order to figure out whether they were congruent or not. All right, last theorem. Yay! Same side interior angle theorem. If two parallel lines are cut by a transversal, then same side interior angles are not congruent, people. They are going to be supplementary. Okay, just think about it for a second. If I kind of box these, 4 and 6. 6 is acute. 4, you can tell, is obtuse. Acute and obtuse cannot be equal. They're going to be supplementary. So if J is parallel to K, I'm looking at the symbols, then the following are true. So this would be, we would say the measure of angle 4 plus the measure of angle 6 equals 180. And the measure of angle 3 plus the measure of angle 5 equals 180. Okay, and then in short form, you could say if parallel lines, therefore same side interior angles, sup for supplementary. Okay. Oh, I meant to cut that out. So this is a little visualize it. We'll actually look at it bigger. Let's visualize it right here on the next page. So when you're looking at same side interior angles, you get that C. So I'd be looking at this angle right here, and then this angle right here. I made them different colors because they're not the same. We have obtuse, acute. Okay, and it's just the reverse on the other side. So here's another example. Find the measure of the numbered angle. So you have to decide what relationship you have before you can do this. So as I look at my 80 right here and my 5 right here, those are same side interior angles. So I look at the theorem about it. And those should be supplementary. Okay, now I can figure it out. So I'm going to have to do 180 minus 80